The final counting circuit is a combination of the following subcircuits: the analog input, the NAND gate oscillator, the decade counter, and the binary counter. This is the final counting circuit prototyped on a breadboard. This is the soldered PCB version of the circuit in a custom 3D printed case. It features the following main components along with many other smaller ones: two slide switches, a push button, 0.1 and 100 microfarad capacitors, the 4011, 4017, 4510, and 4511 ICs, and a 7-segment display. When this switch is activated, the circuit turns on and the 7-segment display illuminates. A square wave signal outputted from the NAND gate oscillator is activated when the button is pressed, triggering the counting. The 4017 IC receives the square wave on its clock pin and outputs another square wave on its divide by 10 pin, connected to the clock pin on the 4510 IC. This IC counts the high and low cycles in the square wave it receives and uses it to count in binary. It displays various highs and lows on its 4 output pins, which represent binary values from 000 to 1001. These high and low binary sequences are decoded into decimal values by the 4511 IC, which has 4 input pins, ones for each corresponding output pin on the 4510 IC. It also has 7 output pins, given a letter value from A to G. The 7-segment display has 7 main LED segments, also all given a letter value from A to G. The common cathode pins give each segment its required connection to ground. The segments light up when a high is given on their input pins. The 4511 IC gives highs on its output pins, which are connected to the 7-segment display's input pins, making the various segments light up and display the correct decimal value. The counting can be reversed by sliding this switch, which puts a low on the up-down pin on the 4510. The speed and duration of the counting is determined by the resistor and capacitor values in RC1 and 2.